In this video, we're going to look at the slope-intercept form for the equation of a line. We just looked at the slope formula to compute the slope given two ordered pairs on a line. Here's that formula. Now we want to look at how we can find the slope of a line if we're given the equation of a line. For example, what is the slope of the line given by the equation 2x plus 3y is equal to 6? To use the slope formula, we would need to know two ordered pairs. And we know how to find two ordered pairs by constructing a table of values. If we substitute x is equal to 0, then this term becomes 0, and we have 3y is equal to 6, and dividing by 3, we get y is equal to 2. That gives us one ordered pair, and if we substitute a value of y equal to 0, this term becomes 0, and we have 2x is equal to 6, and dividing both sides by 2, we get x is equal to 3. Now we have two ordered pairs, and we can plug those into the slope formula. Let's use the second ordered pair as the x2, y2, and the first ordered pair as the x1, y1. So that's y2 minus y1, or 0 minus 2 in the numerator, over x2 minus x1, 3 minus 0 in the denominator. And this is equal to negative 2 over positive 3. So we get a slope of negative 2/3 for this line. This would be one way of computing the slope given the equation of a line, but there's an easier way. Let's see what happens when we isolate the variable y in this equation. To isolate the variable y, we subtract 2x from both sides to cancel that. That gives us 3y on the left and 6 minus 2x, or minus 2x plus 6 on the right. Next, we have to divide both sides by 3. That cancels the 3 on the left, and on the right side we have to distribute and divide both terms by 3. So this equation, y is equal to negative 2/3 x plus 2, is equivalent to the one we started with, so it gives us the same line. But notice the coefficient of x is equal to negative 2/3, exactly the same value we got for our slope. And that will always be the case. So when we're given the equation of a line, we can solve for y, or isolate the variable y, to get the slope. It will always be the coefficient of the variable x. Notice that the constant term, plus 2, is equal to the y-coordinate of the y-intercept. That will always be the case as well. When we isolate the variable y and write the equation in this form, we can see both the slope and the y-intercept. And that's why we call this slope-intercept form. Here's the formal definition. When the variable y is isolated, we have the form y equals m times x plus b, where m is the slope of the line and b is the y-intercept. If we write the y-intercept as an ordered pair, b is the y-coordinate and the x-coordinate is 0. So we get both the y-intercept and the slope of the line when we write the equation in this form. Remember that the slope is just the number or the coefficient in front of the x. The variable x is not part of the slope. Let's look at an example. In this example, we're going to find the slope and the y-intercept of this line and sketch the graph of the line. This line is already in slope-intercept form, so we can see that we have a slope of 3 and a y-intercept of 4, or 0, 4. So we have one ordered pair for this line, and we just need a second one in order to sketch the graph. Let's go ahead and plot this point first. Here's our y-intercept. Now we'll use the slope of the line to find a second ordered pair. When the slope is a whole number, or a decimal, we can write that with a denominator of 1. Anything divided by 1 is equal to itself. But now we can interpret this as rise over run. These are both positive, so that means we'll go 1 unit to the right and 3 units up. You can picture the slope with this diagram, 1 unit to the right, 3 units up, and you can apply that to any ordered pair on the line. So here, we'll go 1 unit to the right and 3 units up to get to the next ordered pair. This takes us to a second ordered pair on the line, and we can calculate the coordinates of this ordered pair using the original ordered pair and adding 1 unit to the x-coordinate and 3 units to the y-coordinate. So 0 plus 1 will be x equal 1, and 4 plus 3 will be y equals 7. And that gives us the graph of the line. You could also fill out a table of values and use the y-intercept as one ordered pair and the slope to compute the coordinates of the second ordered pair. Here we start with the ordered pair from the y-intercept, and now for the second ordered pair, we know that we want to add positive 1 to x and positive 3 to y. And that gives us the ordered pair 1, 7, just as we got here. You can also construct a table of values the same way we did in the previous lesson. You can plug in any number you want for x and evaluate this to get the y-coordinate. So when x is equal to 1, we get 3 times 1 plus 4, which is equal to 7. When x is equal to 2, we get 3 times 2 is 6, plus 4 is equal to 10. So 2, 10 will be another point on this line. But the point of this lesson is to use the slope to find other ordered pairs. Let's look at an example where the equation of the line is not given in slope-intercept form. In this example, we're asked for the slope and the y-intercept of the line given by this equation, and we will sketch the graph of the line. This equation is not in slope-intercept form, so we need to first solve for y, or isolate the y variable. We'll start by subtracting 3x from both sides of the equation to get rid of this x term on the left. That gives us 2y on the left is equal to 14 minus 3x, or minus 3x plus 14 on the right. It's usually better to write the x term first, so it matches the slope-intercept form, but you could write this as 14 minus 3x, as long as you keep track of which one is the x term and which one is the constant term. Next, we'll divide both sides by 2. And now we have y is equal to negative 3 halves x plus 7. This is slope-intercept form. From this, we can see the slope of the line is negative 3 halves, and the y-intercept is 7. It's a good practice to write the y-intercept as an ordered pair, x equal to 0, y equal to 7. You can see that from this equation. If you substitute a value of x equals 0, this term becomes 0, and you're just left with y equals 7. Now to sketch the graph of the line, we'll start by plotting the y-intercept. And to find our next ordered pair, we're going to use the slope. We'll go ahead and put the negative in the numerator, so that this is negative 3 over positive 2. That means that our horizontal change is positive 2. We're going 2 units to the right, and the vertical change is negative 3, so we'll go 3 units down. And we'll apply this diagram to our ordered pair, 2 units to the right, 3 units down. This new ordered pair will have an x-coordinate of 0 plus 2 and a y-coordinate of 7 minus 3, or 4. So here's the line given by this equation. And if you find it easier, you can write these ordered pairs in a table of values. Starting with the y-intercept as the first ordered pair, we then add 2 to the x-coordinate and subtract 3 from the y-coordinate. And then you plot these two ordered pairs and sketch the line that passes through them.